Yes, hi guys, a very good morning everyone. Quickly confirm me the audio and video if everything is good to go. Let's get started with this important question practice sessions, that we are running on BARC for the upcoming BARC examination 2024, which is going to be held on 16th and 17th of March. Okay. Right. Okay, very good morning everyone. Come on everybody, quickly keep on joining and update all your friends that the session is now live. Yeah, I think audio video is all good, but still you can let me know if there is any concern regarding audio video at your end. So guys, time to get started. Let's get moving ahead quickly. Okay, the session on digital electronics for the upcoming BARC examination. Already I took one session on control system. Next week I'm going to take the session on signal and system. Okay, and similarly Sanjay Rathi sir is taking the session on network theory. That will be on Friday. Monday session was taken by Saket sir. That was for communication systems. So multiple sessions are going on for you. Right guys, so before I get started, a quick update for all of you, and quick and important update that all your favorite Richa ma'am is going to bring you a free live interactive workshop, and that's just today, 28th of February, Wednesday at 7:30 p.m. and these workshop will be held on the Byjus exam prep app. So if you don't have the app, you can download it from the Google Play Store. So yes guys, how to ace GATE, okay, along with college and job, okay, on the Byjus exam prep app today at 7:30 p.m. right? Very good morning, keep joining. So guys, let's start with the questions. Okay, this is the first one for the day. Come on. First one as well as a simple one. So if 225 is a number in base y and that is equivalent to 165 in base 8, that is octal, find the value of the base y. Find the value of the base y. Find the value of the radix y. Yes, come on, we can try this, a simple one. We can try this undoubtedly. Okay, so what it is, 225 is given to you in the base 5. Okay, 225 is in the base y. Okay, so converting both to decimal, okay, 2y square, because the positions are 0, 1, 2. This is also 3-digit number, position 0, 1, 2. 2y square plus 2y power 1 plus 5y power 0. So that will be only 5. Should be equivalent to, okay, 1 into 8 square. It's a base 8 number, octal number. Okay, plus 6 into 8. Plus 5. So 5 is straight away cancelled. You are left with a quadratic equation, 2y square plus 2y, that is going to be 64 plus how much? That is 48. Okay, so that looks like 112. 2 se cancel kar denge. So y square plus y and then cancel the 2 equal to 56. Yeah, bring 56 on the left side. So y square plus y minus 56 equal to 0. Simple calculation. Okay, minus 56 and plus 1. Okay, so y plus 8 factors are y plus 8, y minus 7 equal to 0, and hence the value of y is minus 8 or 7 as per the equation. But since it is the radix, it is the base, okay, that cannot be negative. Base should always be a positive integral value. Okay, so this is never possible. So the answer has to be 7. The correct answer has to be option number A, that is 7. Done, Eji? Done, Eji? Memory interfacing and coding, matlab you can expect the question on any of these, Venkatesh. Okay, any of these. Chalo, done. Next question then. If the in 2's complement system, okay, add the sign numbers given to you, the 2 sign numbers given, determine in decimal the sign and value of each number and their sum. So what I can do is if I start with the first number itself, okay, 11110010, because I need the decimal value along with the sign of each number. So then the addition also can be done in decimal. Na? That's simple logic, right? So 11110010 indicating that it's a negative number. And how negative numbers are stored? Positive numbers are stored directly in the binary form, but negative numbers are stored by taking the 2's complement of the binary form, 2's complement machine. Okay, so when you take the 2's complement of this, dear, when you take the 2's complement, first let me take the 1's complement, 00001101, inverting every bit. Now when you add 1, 0, 1 plus 1 will become 1, 1, 0. So these are going to be the last 2 digits, that is 1, 0. Correct. Now 1110 we all know is 14. Okay, so what is the first number? Suppose this first number is A. So the number A is minus 14. Okay, and the only option is A. Option bhi yahan pe aa gaya, but yeah, still let us complete that. Okay, what is the next number given to me is 11110011. 11110011. Okay, again indicating that it's a negative number. It's a negative number, so this would have been stored by taking the 2's complement. Again I take the complement because complement cancel each other. Okay, so you have 0 0 0 0 1 1 0 0, that is the 1's complement, add 1, so 1101, and 1101 is 13. Okay, so the value of the number B, suppose this is some number B. Okay, so B is equal to negative 13. Okay, so automatically what is A plus B? 14, 13, 17, so negative 20, 14 and 13, 27. So negative 27, answer is A. So addition can also be done in decimal only, na? Then why to solve the addition in binary? Simple. Done, hai ji? Chalo, cool. If that is done, let's get moving ahead towards the next question. To make the following circuit a tautology, the marked box should be. What should be this marked box? What gate can come up here to make the circuit as tautology? To make the circuit as tautology. Okay, even a sufficient hint is given to you. Even a sufficient, नहीं, ये तो कुछ यहाँ पे typo आ गया है. Okay. नहीं, this is x plus y plus y plus y, but हो ही नहीं सकता. This is an AND gate, so forget that. I think there is some typo error. Forget that part. Okay, I want to make it as tautology. Then what should be the result? Okay, tautology means always true, right? Tautology means always true. Okay, inputs to the gate are still x and y only. The inputs to the gate are x and y. Okay, what type of operation should this gate perform? Dekho, if it is OR only, okay, if it is OR only, dekho, if it is OR na, so what is the output F? Already one of the gate is OR, and isko AND hi maan ke chale hum. Okay, so then you have again x plus y if you consider OR gate. Okay, so x plus y into x plus y is x plus y. That's not always true. It depends on the numbers x and y. Acha, agar second case dekhenge, if you consider it as AND x plus y then into xy, okay, multiply xy inside, so x into xy will be xy only, x into y, y into y will be y, so that is going to be xy only, xy plus xy will be xy. Okay, that's again not a tautology. If you take it as NAND gate, so what is F going to be? X plus y multiplied by xy whole bar. Yeah, it is x plus y is multiplied by x bar plus y bar. Okay, so if you open it na, x into x bar is 0, so you are left with x y bar, then plus x bar y, again y bar 0, so this is XOR. Okay, now option number D, if I assume the marked box as XOR gate, so that's x plus y into x XOR y. Okay, so that is x plus y. Okay, x plus y. नहीं, यहाँ पे कुछ तो error है question में. Okay, x bar y plus x y bar. Now if I open it, the first term is 0, the second is x y bar, नहीं होगा ये भी, plus x bar y plus y bar. No, then this is OR gate only. Okay, what they have written is correct. There's a typo error in the question, dear. There is a typo error in the question, dear. Okay, there is a typo error in the question. First of all, okay, there is no point that you should be given this information. इसको हटाते हैं पहले. There is no point you should be given this information, otherwise the question is by default solved. ठीक है, हो सकता है दे no problem, but dear, this particular gate is a OR gate. This has to be a OR gate. This is a OR gate. Done hai ji? Please take it as the OR gate. Okay, now if this is the OR gate, if this is the OR gate, what is the output F? Okay, it is x plus y plus something. Okay, plus the output of the missing gate. Plus the output of the missing gate, right? Any doubts? Keep asking me. Okay. Now I want to make it as tautology and everything is in the form of plus. Okay, in the form of plus. Okay, so what I can say, F will be equal to 1. Okay. F will be equal to 1. Okay, that means if, okay, if suppose this is A plus A bar is always 1, na? So if question mark comes to be x plus y ka whole bar, and dear, what is x plus y ka whole bar? What is the x plus y ka whole bar? It is x plus y का होल बार, एक तो ये पॉसिबिलिटी है, सो दैट इज x बार y बार, बट दैट इज नॉट द ऑप्शन, ठीक है. देयर इज वन मोर पॉसिबिलिटी, f इक्वल टू 1. नाउ x plus y whole bar is also 1, but that is not an option matching. One possibility here is NOR gate also, but there is no option in NOR gate. But I will try something else. So a plus a bar doesn't work. X plus x bar individually ले लेंगे. If question mark is individually x bar plus y bar, x plus x bar will be 1, y plus y bar will be 1. X plus x bar and y plus y bar 1, 1 plus 1 will be 1. So x bar plus y bar is xy whole bar. Do I have NAND gate? Yes. So both are possible here. Both are possible here. Okay, only option that can match here is C, NAND gate. Done hai ji? Yeah, Satya, there will be sessions for electrical core also. Don't worry about that. Electrical core also will be coming up by first week of March. I mean, February is anyways over now, almost. Next one, the following circuit can be represented as, okay, in what form the following circuit can be represented? Okay, have a look into it. In what form the following circuit can be represented? Please have a look into it. Done, Aji. So let's check out the numbers. So this is AB. Okay, this is the NOR gate. This produces the output. This produces the output A plus B whole bar. Okay, yeah, equal to A bar B bar. Correct, NOR gate ka output. Now this is going to be multiplied by A. So what do you get here? A multiplied by the output of this gate, which is A bar B bar. So A into A bar comes together 0. Similarly here, the another input is B. Okay, to be multiplied by A bar B bar. So this is also 0. Okay, so there are some inputs that are becoming 0. Okay, this becomes 0. So yahan pe bhi 0 gaya, and this also gets 0. Okay, now what is this? This is also 0. Yahan pe 0 aaya, but this third variable is C. So dear, what should be the output of this NOR gate? C plus 0 whole bar. So that is C bar. Okay, now again here C bar plus 0 whole bar. So that will be C bar ka bar, that is C. What I am getting here is C. Ye aaya C bar. C plus C bar. Okay, this is C plus C bar ka whole bar. NOR gate hai na. Okay, so C plus C bar is 1, but complement karke 0. Okay, so what is the final output? Yahan aaya C, yahan aaya 0. So C plus 0 ka whole bar, answer should be C bar. Okay, now which of the options is correct? Considering 3 variable, which of the option is correct? Definitely not A. Definitely not A. Okay. Dekho, F is equal to C bar is 1 if C is equal to 0. Output is C bar, so output will be 1 if C is equal to 0, and C is equal to 0. Okay, what are the combinations for ABC? Okay, all alternate even numbers. Okay, LSB 0 representing even number na. Okay, so ye ho gaya 0 0 0 0 1 0 1 0 0 1 1 0. By C fix kar diya 0. C is fixed at 0. AB I have taken 4 combination. Okay, so it is of the form F is summation of the minterms, all even minterms 0 2 4 6. So that is why my correct answer is C. Done hai ji? My correct answer is C. Bilkul done ho gaya. Next question. What is the output Y here? Come on, next question. What is going to be the output Y for the following circuit? What is going to be the output Y for the following circuit? Okay, now this is an XOR gate using A and B bar. Dear, what is the XOR if one of the variable is complemented? What is A XOR B bar? The A XOR B bar is nothing but A XOR B. If any one of the variable is complemented, okay, it becomes the function of X. Now you should know this property, or again you can expand the formula by nothing great, nothing difficult there. Now A XOR B. This is simply A XOR B. Ye hai C bar XOR D bar. Now when both are complemented, it is XOR only. When both are complemented, and in the last one again in the XOR only one variable complemented. C bar XOR D should be equal to C XOR D. Should be the C XOR D. Now if you look into the first two lines, dear, A XOR B and A XOR B, they are complement of each other. Same inputs hai na, A and B. A XOR and A XOR B. That means out of these two lines, one of them will be high, one of them will be low. One of them will be high, one of them will be low. Similarly, out of the next two lines, one of them will be high, one of them will be low. So out of the 4, okay, out of the 4, मतलब अगर आप इन दोनों की बात करेंगे, okay, here you get 1 and 0 combination. Here also you get 1 and 0. Which is 1, which is 0, that depends on AB, but confirm hai, one of them is 1, another one is 0. Okay, now finally you have a XOR gate again. Finally you have a XOR gate again. So that means अगर मैं इस XOR gate की बात करूं, which is a 4 input XOR gate. Okay, in this 4 input XOR gate you have 2 ones. क्या है आपके पास? You have 2 ones. 2 is an even number. Okay, so whenever a XOR gate has even number of ones in the input, the output will be low. Because XOR produces high output at odd number of ones, so output will be 0. You know, it's a pure logical question. Okay, good one, logical question. Answer has to be A. Correct hai? Answer has to be A, 0. Correct answer is option number A, that is 0. Next question. Find the output Y. Find the output Y, a simple multiplexer based question. Okay, so now for the first multiplexer, if I start solving, okay, what is going to be the output? Suppose that is F. Okay, so सबसे पहले आएगा A bar B bar into 0. Okay, then next select line 0 1. This is selected 1 and ये यहाँ पे A आ गया वापस. तो A bar B into 1. Okay, and then 0 not to be written. So A B bar not to be written. Last combination of select line is A B, and with A B what is multiplied is A. इसके साथ था 1. Okay, so the output F is basically A bar B plus AB into A is AB. Out of that, dear, B common. X plus X bar is always 1. So output of the first multiplexer is B. Okay. Now here you get B and this is also B. Okay, so what is going to be the output Y, dear? Select line 0, C bar pe aayega B. Even if the select line is 1, C, that will also take the B. Okay, so again the B is common and C bar plus C is 1. So output is B. Correct answer has to be D. Simple and quickly keep on solving and keep on responding. Yes, the correct answer is option number D. That is Y equal to B. Next, for the multiplexer shown in the figure, the Boolean expression for the output Y. The Boolean expression for the output Y. What is the Boolean expression for the output Y? Boolean expression for the output Y. Done है? बताइए. Now, देखो, which of the inputs to be considered, which of the select line combinations to be considered, where you see 1, okay, wherever you see 0, not to be considered. Okay, so that is first is I1. I1 means 0 0 1, A bar B bar C. Okay, then next आ जाएगा A B bar C bar 1 0 0. Next आ जाएगा 1 0 1, A B bar C, and next will be 1 1 1, that is A B C. Okay, so now dear, how to simplify this? चलो कर लेंगे. I think better to take the K-map and simplify this. So I can write down that output Y is summation of the minterms 1 and 4 and 5 and 7. That looks like more simple. Okay. Okay. Okay, the inputs, the select lines are A, B, C, and now if I fill up, okay, I have 0, 1, 2, 3, 4, 5, 6, 7. Now let us do the pairing. This is a pair, there is a vertical pair, and even there is a pair. Okay, so output Y is going to be A and B bar, A with C, and vertical wala hai outside B and C. Look into the options and match it up. A B bar plus B bar C plus AC. The answer is option number C. The correct answer is option number C. Done hai? Next question. For the Boolean function f is equal to product of max terms is to be implemented using a 4:1 multiplexer as shown in the figure. Okay, which one of the following choices of inputs to the multiplexer will realize the Boolean function? Okay, so I0, I1, I2, I3, S1, S0. So what is there at the select lines? CB or BC? Let's try with the BC. BC doesn't work, then CB pe aa jayenge. Okay, so let us say select lines are in the regular order BC. Agar isse option match nahi hoga, then I will try CB also. Okay, now what is there at the input lines? What is the function given to me is product of the max term form, and what are the max terms here? 0 2 4 7, So what is the minterm list? Okay, those integers which are not in the max term, they come in the minterm. So it comes out to be 1, 3 and 5 and 6. Okay, 1, 3 and 5 and 6. Okay, so if I have to draw the implementation table to decide what is I0, I1, I2 and I3. Okay. Okay, where select line pe BC hai, so what is there at the input lines? It is either A bar or A. Now, what are the combinations where A is 0? Okay, the first 4 combinations, A is 0. Always A is the MSB, na? And the next 4 combinations, A is high. So wherever A is high, that is written in A. Wherever A is low, that is written in the row of A bar. And now I will highlight those minterms, okay, which are given in the function. So 1 hai, 3 hai, 5 hai, and 6 hai. And whenever both are absent, so answer is 0. Wherever both are present, A bar plus A, both coming up 1. Here only A wala term coming up, and here next is A bar wala term coming up. So 0, 1, A bar, 0, 1, A bar. Now with BC, yeah, with BC, I have taken the select lines as BC. Maine bola tha if that does not work, I will try CB. But yeah, that already worked, and here it is 0, 1, A bar. 0, 1, A bar. The answer is D. Done, Ji. Next question to be presented to you. Okay, yeah, so before I take the next question, guys, important update for all of you. Yes, the ground zero series for gate 25. Yes, now the time to hunt for gate 25 is already started. One entire year you have for gate 25, and that is why you need to be conceptually strong and to make your fundamentals and concepts strong. Here we bring on the Byjus exam prep app the ground zero, as the name says, to make your preparation start from zero and take you towards the utmost level. The ground zero series live on the Byjus exam prep app for ECE, civil, mechanical and computer science aspirants. Right. The present output of an H-triggered JK flip-flop is logic 0. If J is equal to 1, then what is Qn plus 1? Simple question. Eh? If J is equal to 1, then what is the value of the Qn plus 1? Chalo. Come on. Yes, dear. So this one looks simple only. Come on. Okay. So the present output is 0 of a H-triggered JK flip-flop. Out of which J is fixed at 1. Okay. And the present output Qn is at logic level 0. Okay. Is at logic level 0. Is 0. Okay. Now, if J is 1, what is Qn plus 1? Can we say only by the value of J first of all? Yes or no? Maybe. Sometimes yes. That depends on the present state also, na? That depends on the present state also. Can you say by the J equal to 1 only? Dekho, you can solve it by 2 different ways. Dekho, agar K 0 hai, only J given hai na? If J equal to 1, that is fixed. If K equal to 0, that means J1 and K0. Okay, then you have the set condition. So Qn plus 1 will be 1. Okay. But if K is equal to 1, okay, J and K both 1 means you have the toggle condition. Okay, and toggle mein Qn plus 1 is the complement of the present state which is given as 0. So then also it is 1. So yes, we are able to determine. Yes, we are able to determine. It will be logic 1. Okay. अच्छा, और आप इसको ऐसे भी कर सकते हो. Okay, what is the Qn plus 1? Next state. Okay, it is given by J Qn bar plus K bar Q. Okay, so J is 1. The current state is 0. Okay, so whatever is K bar, it's not required because current state is 0. Okay, I have 1 into 0 bar, that is 1. And next term is anyway 0. 1 into 1 is 1. So it will be logic 1. By the equation of the JK flip-flop, characteristic equation of JK flip-flop also it can be decided. Done, Ji. Next question then. A pulse train with a frequency of 1 megahertz is applied to a modulo 1024 ripple counter. Okay, built with JK flip-flops. Acha, it is modulo 1024. Okay, 1024 is 2 raised to the power 10. So it is comprising of how many flip-flop stages? Okay, built with JK flip-flops. How many JK flip-flops? So it will be actually having 10 JK flip-flops. Okay, to have a count of 2 power 10, we need to have 10 JK flip-flops. For proper operation of the counter, the maximum permissible propagation delay per flip-flop stage. So now, let TFF is the delay of, okay, TFF बोल दीजिए या regular term में T clock to Q, the delay from the clock to the Q. The delay from the clock to the Q. Let it be T flip-flop or T clock to Q, be the delay of each flip-flop. Let that be the delay of each flip-flop. ठीक है? चलो, done है? So now guys, okay, what is the for ripple counter? Since it is a ripple counter question, okay, what is the total worst case delay it is given by NTFF. If it was a synchronous counter, then it is the total delay also equal to the delay of a single flip-flop, but for ripple counter it is equal to N times TFF. Okay, so what is the TPD? The number of stages, flip-flop stages is 10, and let the delay of each flip-flop is TFF. Okay, so I can say that total propagation delay is 10 TFF. Now, you are given a clock of 1 megahertz. Okay, देखो, for the proper operation, the time period of the clock to be chosen should always be greater than or equal to the propagation delay of the circuit. So that within one clock cycle, I'm not drawing the waveform and explaining, but this is what you already should know. Okay, so that within one clock cycle, one particular operation is completed. Okay, so that means what is the time period of the clock? वो भी लिख लेते हैं यहाँ पे. Okay, there's a frequency of 1 megahertz. So what is the time period of the clock? Okay, that is 1 upon frequency. Okay, so that becomes 1 microsecond. 1 microsecond. So this value TPD, what is TPD? 10 TFF should be less than equal to 1 microsecond. Yeah, should be less than equal to 10 raised to the power minus 6. So dividing by 10 further, the delay of flip-flop should be less than equal to 10 power minus 7 seconds. Options nano mein hai, no problem. Okay, so TFF should be less than equal to multiply by 100. Okay, now it becomes 10 power minus 9, which is nanosecond. So 100 nanoseconds, option number A. Okay, TFF is less than equal to 100 nanoseconds. 100 nanoseconds. Correct answer hai. Next question for you. The above synchronous below यहाँ पे synchronous sequential circuit built using JK flip-flops is initialized with Q2, Q1, Q0 equal to 0, 0, 0. What is the state sequence for the circuit for the next 3 clock cycles? What is the state sequence of the circuit for the next 3 clock cycles? You have to just count the pattern here. Provided initial 0, 0, 0. If not mentioned, then also by default we take the initial 0, 0, 0 only. Okay. Done? Tell me. Come on, let's do it up. So here it is, starting with 0, 0, 0, synchronous circuit hai, synchronous counter hai. Now, what is the next state? Okay, what is the next state? So, let's have a look into it. If Q is 0, its Q bar will be 1. Okay, so all Q bars I have written as 1. Now, look into this JK flip-flop. Okay, J0, K1 reset, so it is reset, it will remain at reset only. Okay, इसमें state change नहीं होगा. अच्छा, what about the inputs here? इसको भी लिख लेते हैं. This is coming here 0 and ये आया है यहाँ से, this is 1. Okay, so J1 K0 set. Okay, तो ये हो जाएगा set. यहाँ पे next output should come up as 1. Okay, here what I'm going to get is 1. Okay, this was J0 K1, so this remains to be reset. This was also J0 K1, this remains to be reset. So what is the next output I'm getting? There is only a transition at the first flip-flop that becomes 1, rest 2 are 0. Okay, so I will modify it. Okay, this is 1, 0. Rest everything remains to be same. Perfect. Okay, so the next state is after 1, 0, 0. That means option number C or D. After 1, 0, 0. Okay, now let us start. Now look into this flip-flop. Okay, this is J1 K0 again toggle. इस पे भी J1 K0 है, ये भी toggle होगा. Now look into this flip flop. J0 K1 reset. So this will be reset only. J1 K0 this will be toggle से मेरा मतलब था set होगा basically. J1 K0 set. So this will be set. Okay, here also I have J1 K0. So this is already set. Will remain at set. Will remain at set. Okay. So what is my output then? 1 1 0. Now only second one changing. 1 1 0. Okay, my answer is C. Still I can find the third also. Okay, but option match हो गया है. 1 1 0 पे stop करेंगे. Okay, 1 1 0. Option is C. In the exam you can stop, but here let me continue. So here I have got this is 1. Okay. Now if this is changed, तो यहाँ पे भी change आएगा 0. This one is not changed. Okay, now have a look into it. Here J0 K0 in the first one, so no change. ये 1 0 रहेगा. Here the input is 1 0, so it remains to be set. Here also input is 1. अरे I think इसको मैंने incorrectly read कर दिया था क्या? Oh, I was taking this as 0. Forget. I don't know. I think. Maybe this is the answer, but I think I will restart better. Because actually it is coming from here. So what is the initial state? 0 0 0. So this 0 comes here. ये हो जाएगा 1 and 1. This 1 comes up here and this is 0 1. तो यहाँ पे आएगा 1 basically. Okay. ठीक है. This is going to be 1 here. Okay, now let's restart. Okay, तो J1 K0, okay, J1 K0 set, तो ये हो जाएगा, इसका next state हो जाएगा set. Currently the inputs here are J0 K1, that is reset, so it will be at reset. Okay, and here the inputs are J0 K1, J0 K1 again reset, so this remains to be reset. Okay, so I am starting with 1 0 0 only, उसमें कोई change नहीं है. Okay, 1 0 0, so only this change, this one and this is 0. Rest there is no change. Okay, now next state पे चलेंगे. Now in the next state have a look into it. J1 K0, so this is set anyways. J1 K0 तो ये भी set होगा, ये भी set होगा, तो ये reset हो जाएगा. Okay, now this is J1 and this was K1. J1 K1 this will toggle. Yeah, so there is a change. There is a change. Okay, this will toggle, so this will become 0. ठीक है. So the next is 1 1 1 basically. यार ऐसा कोई option आ नहीं रहा है. Next is 1. J1 K0 no problem, set and then नहीं अरे इसको क्यों remove किया? I only need to remove it. Okay, so what I had is 1 0 0. I will show you once again. Okay, yeah, now have a look into it. This was equivalent to 1 and this was equivalent to 0. Okay, now all the inputs are ready. Correct. J1 K0 set, it remains to be set. J1 K0 this is going to become set. J1 K0 this is going to become set, but the current input is J0 and K1. J0 K1 reset. So next is 1 1 0 only. Undoubtedly it is 1 1 0. इसको हटा देते हैं, इसको कर देते हैं 1 0 and if this is 0 this remains to be 1 1 1 0. Correct. Answer is C only. Answer is C only. But still अब next एक और देखेंगे. Next एक और देखेंगे. Okay, now if this is 1 1 0, all inputs should be modified here. This 0 should come here and this remains to be 0. This was 0 and this comes out to be 0. Perfect. Now let's read it. J0 K0 no change. Okay, तो ये no change रहेगा. Okay, okay, 1 0. Okay, J1 K0. Okay, set. Okay, J1 K0 set, so this is already set. Okay, now J1 and K1 ये toggle होगा. Correct. J1 and K1 ये toggle होगा. This will be 1. Okay, so the correct state is then 1 1 1. As I already told you, answer is C. As I already mentioned, the answer is C. Okay, next question to be ready. Correct. Yes guys, ready for the next question. Here it is. Yes, let's do it up. हाँ उससे भी कर सकते हैं सुबोध by next state table also. चलो, a 4-bit SIPO serial in parallel outshift register is used with a feedback as shown in the figure below. Okay, the shifting is just a second here, something urgent. Done it. Yeah. So if the output is 0000 initially, then the output repeats after how many clock cycles? Okay, where you have to take the XNOR of QB and QD. You have to take the XNOR of QB and QD, and that output of the XNOR gate goes to the serial input, which will be transferred to the MSB on the next clock. Okay, so let's make this. Okay, let's make this QA, QB, QC, QD. And what is the serial input? It is the XNOR of B and D. It is the XNOR of B and D. Correct? Chalo. So let's start filling it up. Initially 0000. Okay. Acha, in dono ka XNOR lena hai. Whenever they are same, the serial input will be high. Now do the right shift operation. Serial input comes to the MSB. Then this is right shift. As clearly mentioned, it is a right shift operation. A to B to C to D. Done hai? Now next is 1000. Now B and D again same. So serial input 1. Now no need to draw the arrows. Just I will shift 1, then 100. Now B and D are different. So this is 0. So 0, 1, 1, 0. B and D are again different. So this is 0. So 0 and then 0, 1, 1. B and D are again different. So this is 0. Okay, so यहाँ पे आया 0 and then 0, 0, 1 forward. B and D are again different. So this is 0. Indar आएगा 0 and 000. Oh my god, repetition starts. So repetition is after how many clock cycles? Yes dear, the repetition is after how many clock cycles? ये तो initial था ही 1, 2, 3, 4, 5, 6. Okay, this comes at 6. Okay, 6 clock cycles. The repetition is after 6 clock cycles. Done है जी? Okay, repetition is after 6 clock cycles. ये तो initial हो गया 1, 2, 3, 4, 5, 6. Okay, chalo. Now attempt the next question and answer me. Come on. What is the frequency of the pulse at the point C in the circuit? What is the frequency of the pulse at the point C in the circuit? Check करेंगे एक बार. Okay, so ring counter. Now, if it is a 10-bit ring counter, what is the number of states? 10 only. If it is a 4-bit Johnson counter, the number of states is double of the number of bits. Okay, that is mod 8. And this is directly mentioned mod 10. Okay, what is the frequency at C? Now, whenever counters are cascaded, the mod numbers are multiplied. Okay, yeah, they can ask the frequency at any point. So let us not calculate directly the final frequency. What is the frequency at the point A? It is given by the clock frequency divided by 10. Okay, what is the clock frequency? 10 megahertz. So 10 by 10, 1 megahertz. Okay, then what is the output? Frequency at B, that is the input to the Johnson counter will be the frequency A divided by the mod number, which is 8. Okay, so 1 megahertz, अब kilohertz में convert कर देंगे, so that is 1000 by 8, 125. 1000 by 8, 125 kilohertz. 1000 kilohertz by 8. Okay, last, the output C. The frequency at C should be equal to the clock frequency, should be equal to the frequency B divided by 10 again, and that's going to be 12.5 kilohertz then. ठीक है, और you can multiply the mod numbers 10 into 8 into 100 and then divide by the overall mod number, वो भी कर सकते हैं आप. तो anyways the answer is 12.5 kilohertz. Anyways your correct answer is 12.5 kilohertz. Okay, next one. What is the frequency and duty cycle of the output Y when the clock frequency is 1 megahertz at 50% duty cycle? At 50% duty cycle. What is the frequency and duty cycle of the output Y when the clock frequency is 1 megahertz and 50% duty cycle? At 50% duty cycle. Let's look into it there.